Our next presenter here, again on a request from our steering committee or group that is here, as far as dealing with straw and crop residue, was to say, well, we need someone in here to talk about how to address this. That came from your group, Anne. And so we thought, well, we've got the person for this. Ashley Ammeter is from that high straw producing area, Starbuck, Manitoba, in the heart of the Red River Valley. You did your master's and bachelor's here at the University of Manitoba. You grew up on a grain and oilseed farm in Starbuck area, and you're the whole farm specialist with Manitoba Crop Alliance, meaning that she needs to provide, you develop extension materials and things like this to take to growers. One of those materials that you authored recently was on this very thing, taking some data from across Western Canada and developing options and alternatives for people dealing with lots of straw. So that's why we've invited you in here today. You're going to step up to the plate and you're queued up and ready to go. Welcome, Ashley.
Thank you.
I should say I've threatened to introduce you as Ashless Ashley Ammeter, because that's one of the options we're probably not going to talk about.
We're going to talk about it.
Okay.
So, good afternoon, everyone. As John said, I come from the Red River Valley, where excess residue tends to be a problem. I have to confess, I have burned crop residue before, so maybe this is a bit of a confessional for me. When they asked me to tackle this topic, I was a little worried about covering it in 30 minutes, and so this is a tasting menu, so to speak, of some past and present research on the topic. Hopefully it spark some ideas for you of what could be incorporated in your area or with your clients, or if you're a farmer, maybe for yourself. And so without any further ado, I am going to get started. So before we get into managing residue, let's talk about why we actually care about it. Of course, residue contains organic matter. This is valuable in terms of maintaining and holding soil moisture. Soil structure and aggregation is critically important. Herbicide breakdown, as well as erosion control. So the picture you're seeing here is one that I took just this weekend, actually, on the number 2 highway. If anyone has driven in that direction recently, there are an awful lot of black fields, or there were before the recent snow. And so this particular field, when I dug into that, it was about an inch thick of topsoil that had been blown into the ditch. So not ideal. When we're talking about erosion control as far as straw goes, we want at least 35% crop residue cover. If you're in a high-risk area or a high-risk field, that gets bumped up to about 65% as a rule of thumb. So, other than organic matter, of course, straw contains valuable nutrients. Now, most of the nutrients we remove from a field are actually in the grain, so it may not be as much as you might expect in the straw. These are some numbers from the Manitoba Agriculture Straw Cost Calculator. These values vary significantly depending on the growing conditions, the environment, of course, what crop you're growing, whether or not there's been a rain on the straw to leach some of that potassium out. But these give you a ballpark idea. Having said that, the rate at which those nutrients become available varies depending on the type of straw, so the carbon to nitrogen ratio. A ratio less than 20:1 is going to end up with net mineralization. Greater than 20:1, immobilization. The size of the residue really impacts how fast it will decompose. Of course, our environmental conditions, so the temperature, moisture, soil type, as well as tillage, which can factor into the soil to residue contact. Now, we know why we like to maintain residue. What about when it can become a problem? So, as Darren, who I don't know if he's still here, as he talked about, in some parts of the world, residue can become a big problem in terms of reducing water evaporation from soil surface, impacting soil temperature. So this is some research that was done in the late 70s, early 80s here in Manitoba. On the on the left side, Those are early June soil temperatures. So we're seeing significantly higher soil temperatures when straw was removed and the land was tilled compared to when the straw was maintained. And then on the right side, this are winter soil temperatures. So much more consistent soil temperatures over the winter in zero-till situations compared to conventional tillage. This is why crop residue management can be a very important consideration for our winter cereal crops. Of course, we also know that crop residue can also be a problem at seeding time by resulting in hairpinning, so impacting that seed-to-soil contact, as well as uneven seeding depth. This is some research from Oregon, looking at spring wheat planted into winter wheat stubble. These folks found that plant stand was significantly impacted by residue management, so specifically baled winter wheat stubble resulted in significantly higher plant stands compared to others, but when it came to yield, baling and chopping and spreading were similar. A little closer to home, PAMI, so Prairie Agricultural Machinery Institute, has done some research looking at the effect of cereal crop residue management and distribution on the following year's canola emergence. In this case, they had an original equipment manufacturer chopper that they had poorly set and compared it to an aftermarket chopper that was properly set. Based on this research in Saskatchewan, actually, they found few significant differences in canola emergence. However, in cases like on the right-hand side picture there, where the straw was poorly spread, emergence was significantly higher outside of the heavy residue area compared to the chaff row. The one exception was a drought year, where that chaff row helped maintain higher soil moisture. In terms of canola yield, they also found few significant differences. However, the well-distributed residue did yield higher in 1 out of 3 years. So we've talked about why residue can be a problem. Now let's talk about actually managing it. One thing I want you to take away from this talk is to not only think about managing your residue at harvest. Think about it right from the very beginning of the season. So in terms of your crop selection and rotation, rotating high and low residue crops, variety selection, choosing potentially shorter varieties if you're concerned about residue, if that residue is of benefit to you, potentially taller varieties, the use of plant growth regulators to minimize plant height, and then managing your soil fertility to minimize the chances of excess vegetative growth from nitrogen. That same PAMI project that was done with the poorly set original choppers compared to aftermarket choppers also looked at the distribution of crop residue across the header or across the harvest area. Perhaps not unsurprisingly, the poorly set chopper resulted in much higher chaff and crop residue in the middle of the header compared to the edges. The aftermarket chopper, we saw a much more even fractional distribution, or a much more even distribution, and the size of those fractions was significantly smaller compared to the poorly set chopper. Talking now about stubble height. This is research that was done at, I believe, 11 site years across Manitoba, Saskatchewan, Alberta. These researchers looked at the effect of wheat stubble height on subsequent canola performance. They found that plant population, no significant difference. Biomass, no significant difference. But yield, there was a significant difference between tall and short stubble. In this case, tall stubble would be 50 centimeters compared to short stubble, which is 20 centimeters. Sorry, I don't have inches. They were on my notes, which I can't see. So the reasoning behind that, as discussed in this paper, is actually really quite interesting. So This paper, which was actually written probably by some people who may or may not be in the room, talked about how in the springtime, the years of this study, they were actually quite moist conditions. And so the yield benefit seen between the tall and the short stubble was not due to extra snow capture for spring moisture. It was actually because it mitigated mid-season moisture stress when it occurred during these years. Now, the other caveat for this data is that the data I'm showing here is for what they're calling intact stubble. In in several of the site years, the tall stubble actually didn't overwinter very well. It flattened out by the time it got to springtime. In those cases, plant population and biomass and yield were all negatively impacted. So, so minor detail there.
Oh yeah, just minor. Okay.
Yeah. So what do we get from that? If we can keep the standing stubble standing, we're golden.
Easy.
No problem. If we can't, that's when it becomes a problem. So in the areas such as the Red River Valley, where excess moisture tends to be a concern, where drought is less of a concern, especially in the spring and towards mid-season, perhaps tall stubble isn't for you. If you are in a case where drought is a concern, perhaps tall stubble could be the right practice for you. I'm not going to spend a ton of time on this, but as we all know, we can use standing stubble to capture snow. This is from some research that was done in Saskatchewan in the 80s and 90s. Long story short, they looked at all kinds of different practices and the amount of snow water equivalent that was captured. In all cases, doing something other than cutting your stubble short captured more snow. So again, if you're in the Red River Valley, maybe not so much a concern for you. If you're out west, this could be something to consider. Now we can get to what happens at harvest. By the time we get to harvest, we have essentially two options. Either we keep the residue on the field, or we take it off. What the specifics of that are can become a little bit more interesting. I'm just touching on a couple of options today, but really the options are nearly endless. So first, talking about harrowing. Harrowing is, oh, great, thank you. Okay. So harrowing is really effective at redistributing straw, less so with chaff. It is especially effective in dry conditions. Harrowing does increase straw to soil contact and will bury a small amount of straw, but not a lot. One of the big considerations for, well, any pass over the field, but especially for harrow and tillage, is that it's going to consume fuel. Now, talking about tillage, it will bury straw, it will increase straw to soil contact. The amount that it will do so depends significantly depending on what kind of tillage implement you're using. As we've already talked about, tillage can increase soil temperature and result in moisture loss, which can be a benefit or a cost, depending on your particular concerns. Now, there are other issues with tillage that should also be discussed. So, it will disrupt soil structure, it will result in organic matter loss, we risk the formation of plow pans, so compacted layers under the soil surface, and then of course, as we already talked about, fuel consumption. So these are some ballpark figures from the Manitoba Agriculture Soil Management Guide, looking at the amount of straw buried per pass with various tillage implements. And so the intensity of our tillage will significantly affect how much straw is buried per pass. Some of these are older tillage implements, so they give you a ballpark but not exact. In a minute we'll talk about some potentially newer implements. Now, I want to take you through a couple of studies looking at some of our more challenging residue types. These have all been done in either Saskatchewan or Manitoba or both. So first, looking at the effect of tillage on flax residue, and then subsequent crop yields. In this case, the subsequent crops were wheat, peas, and canola. These folks compared vertical tillage to a tandem disc to no-till. they found that the tillage operations didn't significantly affect aggregate size. However, using a tandem disc did lower aggregate stability more so than vertical tillage, which lowered aggregate stability more so than no tillage. However, crop yields weren't significantly impacted, meaning they had equivalent crop yields in the no tillage treatments compared to both of the tillage treatments. However, fairly large caveat again on this one, their success in direct seeding into flax residue was directly attributed to the dry conditions at harvest. So those dry conditions made the chopper much more evenly distribute the residue. And so if you can, I know it's tricky, if you can try and make sure your conditions at harvest are good and facilitate that, I know that's maybe like a dream, but we can try, right? That will go a long way in your residue management challenges. This is more recent research that was done in Manitoba, including by John Hurd here, on phosphorus, yeah. So the primary focus of this research was looking at phosphorus placement with strip tillage. However, there was a component looking at strip tillage on effect on cereal residue and subsequent corn response. In these cases, there was no significant difference between conventional and strip till for early season biomass, days to planting, from planting to silking, grain moisture, and grain yield. Research was done in Carmen and Portage Prairie. Similar results have been seen in North Dakota. However, I don't want us to think that this would necessarily apply everywhere. Especially in some areas like the Red River Valley, reducing our residue management can be a bit of an issue. So last one I'm going to talk about is tillage tools for corn residue management. This is from a thesis of a master's student here in Manitoba. They looked at the effect of different tillage implements on corn residue and then subsequent soybean yield at 4 locations in Manitoba. All of the locations were sandy loam or loamy sand soil, so keep that in mind. This research found significant differences in surface residue cover. So these are the numbers that you can see behind me here. Some of our newer tillage implements like vertical tillage and strip till. An important note about vertical tillage is that is used for quite a wide range of practices. True vertical tillage is a disc with no angle on it. The term vertical tillage is also sometimes used for discs with slight angle. In this case, they're calling it vertical till high disturbance. And so that is just a 6% angle compared to a 0% angle on that disc. So quite a small angle really significantly decreases surface residue cover. Looking at strip till, within the row, much lower residue cover compared to double disc or even our vertical tillage treatments. But then between the rows, we're maintaining a lot more of that residue. So this is why in some areas, such as in the Red River Valley, strip till could be a potential option. We're getting that reduced residue cover in the space where we're planting our seeds, so we're getting that moisture and potentially faster heating up of the soil, but we're able to maintain more of that residue cover to hopefully mitigate some of our erosion losses. In all of these treatments, the researchers didn't find any significant difference in soybean plant stand. And so, really, what the decision comes down to is economics for a farmer. So these researchers, in conjunction with PAMI again, also did some economic analyses. In their study, they required 2 passes for double disc and both of the vertical tillage treatments, and strip till only required 1 pass. And so the result was a much lower economic cost to strip tillage compared to the other tillage treatments. Now, these numbers are for 2017, so we can look at them relative to one another, particularly the cost of fuel will have gone up. Switching gears here a little bit to what happens when we start removing that crop residue. Of course, we gain the benefit of potential income or livestock feed depending on whether or not we have livestock on farm. In areas where that excess residue can be a concern, we do mitigate some of those concerns. However, we are losing nutrients and organic matter, like we talked about, and we're also risking compaction to soil, especially if we have moist soils in the fall. So these are some numbers from a series of research studies done in Saskatchewan, the same authors on all 3 projects, looking at how much crop residue are we actually removing when we're baling. And so what the researchers found, we're looking at the last numbers there, is that we're removing less than 40% of cereal straw when we're baling, which is perhaps less than you would expect. And that is only of the total above ground biomass other than grain. That's not considering the root biomass. So we may be removing less of that straw than we would be worried about. This same study was on a long-term crop rotation in Indian Head. So that's a heavy clay, black soil zone. Their rotation was a fallow wheat rotation. And they looked at what happens if we remove the cereal straw in both of those cereal years every year for 50 years. Surprisingly, no effect on grain protein, no effect on yield, no effect on nitrogen, no effect on soil organic carbon. Now, I don't want your takeaway to be, Ashley says we should do a fallow wheat rotation and remove the crop residue every single year. That's not what I'm saying. What I am saying is that in some conditions, particularly our heavy clay soils, where we might be naturally higher in organic matter, where that excess residue can be a concern, we can remove that residue by baling in some years, so say less than 2 out of 3 years, and not have significant impacts on some of those soil characteristics. Now, as promised, I am going to talk about burning. Of course, we all know it's not ideal. It happens much less than it used to, which is a good thing, because not only are we losing the organic matter and nutrients, we are also causing environmental concerns, not only from the smoke, but because of the carbon loss. We're reducing air quality, and then just from a safety point of view, we're risking fire escape. So I don't want the takeaway to be we can burn crop residue. However, if we do, which occasionally happens, especially in our heavy clay, high residue crops, maybe something's gone wrong, we dropped straw intending to bale it and the contractor didn't come, we're out of options. If in those cases, burning becomes a conversation, it's really important to be responsible and safe about it. So of course, using fire guards, supervising the fire at all time, don't burn at night because of the risk of wind inversions, follow all of your local regulations. In Manitoba, here especially in the municipalities surrounding Winnipeg, you would need a burn permit, and consider wind speed and direction, not only from a smoke point of view to prevent smoke from blowing into yard sites or onto roads, but also if there's a bit of a wind, it's safer to burn into the wind as opposed to with the wind, just to reduce the risk of spread, and light your stubble or light your residue at regular intervals so you're not burning huge lengths of time, burning huge lengths of straw at a time. So, a few final thoughts. When we're thinking about crop residue management, the first question we should be asking ourselves is, what are our risk factors and concerns? That might be our risk factors and concerns as an agronomist. It might be our risk factors and concerns for the farmer. And those are going to be very different depending on the farm and where that farm is located. Set yourself up for success by planning ahead. So start thinking about what those risk factors and concerns are early in the season so it can be managed with our crop rotation and other potential tools. Be strategic. And so what I mean by that is just because we have that tillage implement does not mean we have to use it on every acre every year. We can use it on potentially our higher residue crops and leave some of those other crops as reduced tillage. We can also consider maybe not every part of the field needs to be tilled. That's some foreshadowing for Curtis's presentation later. And then also be flexible. As we've talked about, all of the best laid plans can go wrong. Just because we say we need to harvest in dry conditions doesn't mean that's going to happen. And so trying to be flexible, being aware of what your options are, and then using all those tools in your toolbox to hopefully have a successful result. I realize this is very small. If someone is interested in the full reference list as well as the links, let me know. I'm happy to send this to you. Or send me an email. I'm happy to answer any questions. I don't know how we are for time.
We have enough time for a rousing round of applause. Joining you. Thank you very much. That's great. I love it when people stick their nose in the literature and get the information that other researchers have done and put together, and that we tasked you with that. One thing I don't know if you had on there, if people go to the Manitoba Crop Alliance website, you have a fact sheet.
Yes, we
that
do.
summarizes this. Don't know if you wanted to mention that.
Yes, so we do have a fact sheet called Managing Cereal Straw or something to that effect. If you go to our website, you'll find it under our resources webpage. And it does cover a lot of this as well as a few other things. So.
Very good. Thank you very much for taking on that task. And there's a